Then the question came up, how much energy has the lamp? How much does it consume? And for that purpose, we had to have means of measuring voltage, means for measuring what we call today amperes, and means for measuring the candle power. The first thing we did was to construct a testing table resting upon piers which ran about 10 feet into the earth. This table is vibration proof. It was copied after the famous Helmholtz table in the University of Berlin, and Mr. Francis R. Upton designed it. Here, in order to get voltage, we had to go in a roundabout manner. Yonder, here on this shelf, we have 50 standard elements, and those elements gave us a deflection on the scale. We used in those days the Thomson reflecting galvanometer as well as the high and low resistance, according to what we desired to measure or use it for. The high resistance galvanometer was used to get the deflection from the battery, and we designated that as a known deflection because we knew the number of cells that gave it. Then we took the unknown deflection and compared it with the known, and in that manner voltage was obtained. Now, to measure amperes or current, in those days we used deposition cells in which there was two elements, two plates of copper or two plates of silver. In that way, by letting the current pass through these deposition cells, we had to let it go for 15 or 20 minutes and then note how much metal was carried over from one plate to another. And in that way we determined the current that we were using. Edison not only introduced the units of voltage, current, and resistance into practical application during his work on electric lighting, but he also demanded a photometer, an instrument or apparatus in order to test the illuminating power of his lamp. Here we have the old Bunsen photometer. At this end here, we have two standard English candles, the units of light at that time. Here at this end, we placed the incandescent lamp that was desired to be measured. Here on the carriage of this photometer, we have a piece of dull white paper with a grease spot in the middle. Now, by moving the carriage back and forward, a point is obtained where the grease spot disappears. Then, in order to get the illuminating power, we measure from the middle of this carriage to the candles, and from here to here, and the respective illuminating power is as the square of these distances. Edison, when he commenced his one man's battle against mighty odds in his great work on electric lighting, he had not only to make the lamp, but he had to make many other things. The meter, sockets, switches, and a generator, and so on. Well, here we have the first electric light meter. This is a cell in which 2 plates of copper are placed in a solution of copper. When a tiny current passes through, metal is taken from one plate to another, and you weigh the difference and you can calculate the current. In this first experiment, Edison also placed an electromagnet, whose work was, in case a short circuit came on the line, this magnet would cut out the current. Here we have the first motor meter for electric lighting ever made. Edison made this meter in 1881. It's a tiny motor and having a van at one end. But I might say the Edison electrolytic meter, that came to stay and was used by the electric light companies, both in America and in Europe, for more than 10 years. Here is one of the first practical models that was used here in New York and in Europe. Here we have 2 cells in which containing each 2 plates of zinc immersed in a solution of zinc, and the difference in their weight when a current passed was calculated and the bill to the customer sent accordingly. In order that this solution in here would not freeze, Edison put in a thermostatic regulator, which, when it got too cold, would close the circuit and set this lamp a-going. And that lamp would heat up the solution and prevent it from freezing. We had many interesting incidents. One man once, when he saw the lamp going, thought the meter was burning, and he took a hatchet and began to chop it down. Here is an Edison electrolytic meter which registers the current. It's on the balance principle, and as one end of the arm gets heavier, it comes down, and then there is a reversing mechanism that reverses the current, and gradually this goes up and down and registers the current. He also showed the world that it was possible to take the current from the lighting mains and apply it to a motor. Here we see the little motor of 79 driving a sewing machine. The motor shows you the first shunt wound motor ever connected between the mains of a 110-volt line. It made the ladies flutter to see a machine driven by electrical power. There were many that contested at the time that it would be impossible to run lights and power at the same time. In fact, the state of knowledge was very limited at that time, and people knew hardly anything about multiple arc system. That was one of the great achievements of Edison in working out a multiple arc system in which current could be taken off at any point on the line without interrupting any other point.